Good afternoon, everyone. Everybody seated and ready to go? We okay up there? Good. Thank you very much for inviting me to speak today. It is a workshop, as is in the literature, so I would like some interaction from most of you. A few individuals I'd prefer if they didn't say anything, so they didn't challenge me too much on what I'm going to say. I'll do some brief introductions, and I'll go into a little bit about Greater Manchester Fire and Rescue Service, if you don't mind, just so you get the context of where I'm coming from as a manager within that service and where the service has come from. It may be of interest to you, both if you're in the fire prevention, protection, and as some people have called it, I know Sean called it earlier, fire suppression area of work. You may be interested in where Greater Manchester Fire and Rescue Service has come from and where it's headed. So just a brief introduction of myself. Tony Hunter, Area Manager for Operational Assurance and Performance in Greater Manchester Fire and Rescue Service. 7 years in the Royal Navy before joining the Fire Service. I've only worked in Greater Manchester Fire and Rescue Service. I've not moved around other fire and rescue services in the UK. Part of my role involves the procurement, maintenance of fire appliances and firefighting equipment. The operational assurance, I don't know if in terms of those who work for a fire and rescue service, whether you have it within your service, but it's about making sure that we're operationally prepared for eventualities, incidents, that we learn from incidents, and that learning transcends and actually takes place into change within our fire and rescue service. So that's part of my role. I'm also in charge, which is really handy or really helpful for rolling out new equipment and testing new equipment. I'm also in charge of the 7 stations within Greater Manchester City Centre. So that's, for those Manchester City fans, that's within that area. It's around the biggest populated area of Manchester, so extremely busy. I've also, for the last 2 years, been involved in the Future Firefighting Project, which a lot I will be going into today. But again, just to put that position about Greater Manchester, we have a population of 2.1 million in 500 square miles. We have 41 fire stations. We have 56 whole-time fire engines on and operationally available 24/7. Over the last 5 years, through our prevention activity, we've reduced our fires by over 50%. When I joined 20 years ago this year, I worked at the most operationally busy fire station in Europe at that time, and we were doing roughly 7,000 calls a year. That was 2 fire engines at that time. It was a time of development within Greater Manchester in particular, where there was a number of housing estates that had come to their end of their life. They were being knocked down, they were being vacated and empty, and for whatever reason, as we find with these situations, we are having fires in one empty house, and 3-4 houses along, we were finding another one as soon as we put one out. That went on for a number of years. Now, with the Manchester City taking on that area, we see the cost of housing in that area shot through the roof, so we don't see that anymore by any stretch of imagination. But the reason I say about how we've come in terms of our prevention, because it really does have a massive part to play in where we've had to go with our suppression / our operational incident command element of it, because we are not as operationally busy as we used to be. That firefighter experience that we used to gain over years of attending incident after incident is not there. We're attending more road traffic collisions than we are attending fires now. So our learning and our need to learn and educate our firefighters has changed over that period of time. In terms of my interest in future fighting per se, has come from when I left the fire engines and went to do my officership, if you want to put it that way. I did a fire engineering degree. I then never went into fire prevention or fire protection because by the time I finished my degree, I'd moved up that it wasn't suitable for me to do so. But I learnt the basics from that education about those areas of work. And then on the 13th of July 2013, it was a weekend, it was a Saturday evening, and I got a phone call from one of my team in Manchester saying that we'd lost a firefighter. That was at 10:15 on the Saturday night, and at 1:45 that morning, I was telling the firefighter's mother that he was not coming home. His name was Stephen Hunt. In April next year, we've got the coroners, and a lot is still unknown about that incident, and I'm sure will come out. But it really did focus for me the reality of what we ask our firefighters to go into and what we should be doing to protect them. Because all the prevention work I've told you about today, or I mentioned about reducing the fires, is as important in terms of preventing fires happening in the first place, incidents happening in the first place, as it is keeping our own firefighters safe when we ask them to go to those, because we still have incidents. And I think sometimes that is lost, that our constant drive, especially in the UK, for reducing incidents has had a massive effect, a beneficial effect on the public in the UK. But we really do need to maintain the focus on our firefighters' safety as well. So the Future Firefighting Project is very much based on keeping our firefighters safe when they go to incidents in a number of ways, and I'll talk you through them. But also doing the best we can with modern technology to reduce the impact of the incidents that we're attending. So we are very extremely environmental now in Greater Manchester Fire and Rescue Service. We've gone to lighter fire engines. We now know, I don't know if many of you have heard about the systems you can get for telemetry, for telling you how much water is being used at an incident from the gauges. I don't know if anybody has come across those gauges that you can buy. We call it a float project. So at a big incident, we can download the information, tell us how much water from each fire engine has been put on that incident. Over the course of, I think, 6 to 8 years, we've gathered information to suggest that the majority of our incidents where we use water, the quantity of water is no more than 200 litres. And we carry 1,800 litres of water around on every fire engine. And we will send, generally to a domestic fire, 3 fire engines. So we send a lot of water with a lot of environmental impact for actually only needing 200. Now, obviously, there are incidents where you need a lot more than that. But we've used that research to educate our firefighters in terms of environmental changes we can make as a service. And one of those is to try and reduce the water that we use on the incident. And ultra-high pressure water misting is one of those areas which I'll cover in a minute. So, as I said before, one of the unsung things that we push very clearly in Greater Manchester Fire and Rescue Service is making sure that we keep our firefighters as safe as possible, and we use the same diligence, passion and drive for reducing the risk to our firefighters as we do for the reducing the risk to the public. I put this one up again, and conscious to not draw out the differences in the UK Fire and Rescue Service, because I do think some of these similarities, if they're not with you now, will be with you in the future, in terms of the drive for our firefighters to do more and more with less and less. We have recently in Greater Manchester taken on a response role of attending cardiac arrests. So all of our firefighters and all of our fire engines, our pumps, are available 24/7 to attend cardiac arrests. So our firefighters over the last 3 months have taken on that role, and their skill in CPR has always been good. I feel it's increased, but they're taking on an additional workload now to assist the public, obviously, in getting a CPR, cardiac pulmonary recovery, to the scene as soon as possible, and helping our ambulance service to do that. But again, it's one skill, and I know I've spoken to a number of colleagues around the room about this. It's one skill amongst a multitude of other skills we're asking our firefighters to take on. And that's all with budget cuts, or We've had budget cuts in the past. We are expecting over the next 2 weeks to hear about the next round of government cuts, and that will change our service, I believe, to a degree. What degree that will be could be in the region of, we have, as I said, 56 fire engines available 24/7. If they reduce our funding to an extent that there is a potential to, that could be reduced to 30 fire engines over a 24-hour period, over that 24-hour period. So that's a substantial reduction in fire cover. And that fire cover, available appliances, has an effect because, again, we're asking our firefighters to do all this, plus the training, plus the prevention, plus the protection, we really are conscious of that strain that we're putting our firefighters on. In addition to this, if you weren't already aware, it sounds doom and gloom here, 2 years ago we went into a period of significant industrial unrest with the Fire Brigades Union. I don't know if you're aware that we had some periods of strike action taken by our firefighters. Part of that, part of the rationale for that industrial action was the increase of a firefighter's working age from 50 to 60. They were concerned about how, when you joined to do a 30-year service, that was being stretched out to 40-year service, and where the firefighters were physically capable of carrying out that job at the age of 60. I know other fire and rescue services, I know in fact in Australia there is no maximum age, and in fact I met a firefighter who was 76 years old in Australia. I'm not suggesting we would want to go to that or you would like to go to that, but I realise that everybody has their different line. So that's a significant one for us. The reason I raise that again, because it is to do with firefighter safety, is our two main causes of sickness at work is musculoskeletal, so backs, legs, injuries, of which 95 to 90% of those are not actually work-related. So that's quite an interesting one in terms of where those accidents are happening. But the other one, for me, is the mental health issues. For us, mental health is an area of development for us. We do a lot of welfare for our firefighters, especially after their attendance at what we call a critical incident. So we do a lot of critical incident debriefing. So we talk them through the incident, talk them through it, give them support. And unfortunately, recently, only 2 weeks ago, we had a firefighter unfortunately commit suicide on station, which has tested. Not only did we lose a colleague 2 years ago in July at a fire, but we recently lost a colleague on station. And that, again, mental health issues can put a lot of strain on firefighters. Again, the watch mentality, the camaraderie has a big part to play in bringing those together and supporting each other. But we do recognise, especially with the fact that we are now attending cardiac arrests as well, and we're seeing a lot of those cardiac arrests end up in a fatal incident, we recognise we're putting our firefighters through some very challenging situations now. So that's a small picture of that. Importantly with us in this subject, though, is a recognition that the demands of the firefighters, and if you've been available for some of the presentations today, you will have heard a number of those in terms of the building types, building construction that firefighters are encountering, the risks in terms of chemicals, the different types of road traffic collisions that we're attending. We do seem to have this inbuilt, as it was mentioned today, in terms of humanity, of finding different ways to, I suppose, kill ourselves, if you would put it that way, or put ourselves in emergency situations. And as a fire and rescue service, we have to find newer and newer ways to try and bring that to a safe conclusion. The big one also for us is new technology. We don't believe in Greater Manchester that we've used new technology as well as we could have done. I'll talk about innovation in a minute, but there's been a lot of new technology. And when I go through some of this today, and hopefully you'll bounce some questions back to me, I have to, and it's important to recognise that what we've done in Greater Manchester has been led by other fire and rescue services. We've taken snippets of what they've done and put it together and then done what we need to do for our fire and rescue service. It might not be right for every other fire and rescue service in the country or even globally, but it's been right for our fire and rescue service. And if we can pinch, again, I've spoken to colleagues, if we could pinch all the good bits from every fire and rescue service and put them into a new service, we would get that real ideal fire and rescue service. Again, I've talked to you about reduced operational workload. That means operational experience is declining. Mentioned before, acknowledged pockets of innovation. I quite like this cartoon because it does depict how I think in the fire and rescue service sometimes we have reacted in terms of hoping if we just sit there and something magical will happen and it will pull us out of whether it's the financial climate or whether it's operational risk reduction, something magical will just happen instead of looking outside the box and seeing how we can develop. We talked about the codes, or it was spoken about the codes in terms of building construction and design. I think we ask a lot of the private industry to take on board our professional opinion about how buildings should be constructed and learning from how we've overcome incidents involving their buildings. I don't think as a fire and rescue service in Greater Manchester we've been the best at learning from previous incidents. So we're asking the private industry to learn, but we've not been as fast to push that same message ourselves. The other thing, and again, and not to play to the previous presentation, the voice of the customer, I've used this one because it's very much about depicting the fact that our customer, and I work at our headquarters now, my customer is the person on the fire engine, putting the fire out, going into the building, doing that. That is my customer. My drive every day at work is to provide the best quality training, equipment, everything to make their job better, more efficient, and again, making sure they get back to the firehouse in one piece. And we have often been accused across the UK of, if something doesn't work in terms of a new initiative, a new piece of kit, actually blaming the customer rather than the fact that the people who bought the kit bought the wrong kit, didn't implement it in the right way, didn't give them sufficient training, all those things that go with it. Innovation. Again, highlighting the fact that we have taken snippets. I quite like this explanation what innovation is. For us, it's about taking better solutions, individual better solutions, and creating an overall change. And I'll talk you through some of those innovations in a moment. This is, again, a quite good picture for me in terms of if you don't, this is a general model for what they see as the three stages of innovation, if you want to put it that way. And you can use this as a graph to and use mobile phones as an analogy for this in terms of how Apple have transformed and then how other products have made incremental steps. So you'd go from the Apple phone is an obvious one for transformational, but then other ones have made slight changes on that, slight adaptations in their product to incremental rather than breakthrough or transformational. The areas I'll be covering, and hopefully you'll challenge me on some of these areas, and I'd be interested in your input, because again, we have a good way generally of sharing information across the UK, but we don't actually generally take that forward into the practical learning. So I'd be interested in feedback from you in terms of how you would have overcome some of our challenges in a different way maybe, or not seen it as a challenge within your service or your area of work. So I'll be covering LAID, PPE. So PPE, that's personal protective equipment. Again, just in case the acronyms you aren't aware of. Ultra high pressure cold cutting systems, which I'm sure you're aware of, and I'll just show you and describe to you how we've implemented it in Greater Manchester Fire and Rescue Service. Thermal scanning, tactical ventilation. 22mm hose reels is a quite a basic one, but has had a fundamental change in Greater Manchester Fire and Rescue Service. The air unit, or you may know them as drones, we try to stay away from that term in the UK because it has a relatively negative connotations, but within these four walls and the internet, drones is the word. and where we're going in terms of the future. So layered PPE, the background to that. I told you before about the change in risk and challenges that our firefighters are facing. For many years, and again, I spoke to some colleagues here over the last couple of days, we've had a one-size-fits-all PPE. So that's structural PPE, whether you go to a car fire or you go to a bushfire or you deal with an RTC or you deal with a structural fire, it's all the same PPE. And I think that's generally the same for it is in the UK anyway. We decided, following feedback from our firefighters, that there had to be a better way of doing that. For a number of reasons. One, because it was getting expensive to keep replacing structural PPE. Two, they weren't comfortable in using structural PPE in all those environments. And four, in terms of the need for the same PPE for every role was inefficient. You had officers walking around the incident ground, not going into the incident, wearing exactly the same PPE as the firefighters were going in there, and it wasn't the best use of our money. The higher level of protection is a really interesting one in terms of, again, that thermal load. We have, over time, as firefighters in the UK, got to the point where if we put PPE on, we feel like we are invincible. Absolutely bulletproof. Walk in, BA set on, nothing can hurt you. Our helmets have got better, lighter. Our PPE has got lighter, but then again, you fall into that hole of thinking, actually, it's just like walking into any building, no fire. I can just, good hose reel jet, can put anything out, and nothing's going to affect me. I won't go into detail now, but I think one of the things that we do well in Greater Manchester Fire and Rescue Service, and you may do this in yours, but I know that most fire and rescue services in the UK don't, part of my role is reviewing significant events from across the globe. So any big incident involving a fire and rescue service, I get my team to analyse the report, pull the recommendations out, go to the departments where those recommendations may have an impact, and assure me that would not happen in our fire and rescue service. Now, part of that has been looking at all the incidents where firefighters have died over the last 10 years. And I can tell you in the UK, there's a surprising number of incidents that have some link to core body temperature and how the firefighter themselves, not their BA set or the PPE they're wearing, but how they themselves are being affected in the incident. Now, that may be as a consequence of the PPE, maybe a consequence of other things, but part of it for us is that recognition of the link to firefighter fatalities and core body temperature. So that's another reason why we looked at this, and I'll explain what we did about that. So a new approach. We looked at our key requirements. We started from scratch. We asked our firefighters, what do you want from new PPE? And then we went to our manufacturers in the UK, in fact Europe, and said, right, these are our requirements. And that took a new tender approach. That's completely outside of what our normal tendering approach is in the UK. Normally, we write out a technical specification, we send it out, people respond, and then we buy, depending on the cost, obviously, and the fact that it meets standards, that's it. There's some interaction with our crews, but very little, and that's why you find generally in the UK a PPE standard across most of them. Yes, the manufacturers will change to a degree, but it all looks and feels generally the same. There is very little scope for innovation there, unless the providers wanted to do that innovation off their own back. We got professional advice from our tender experts. The reason for that is because in the UK, again, because of the use of public money, challenged all the time about how we're using public funds and how we use them, but also the success of tenderers is a big challenge to us. It's very cheap for a manufacturer who's been unsuccessful in winning a tender to challenge us, and we then have to spend a lot of time going back over how transparent our tendering was, how we can justify what we bought in as an end result. So we went to a competitive dialogue process. And that basically, to put it in a nutshell, was a case of sending a letter of invitation to all PPE manufacturers across Europe to say, we are looking at new PPE. We got them in a conference hall very similar to this and said, right, we are looking at making a different type of PPE. These are basic requirements. If you're interested in doing so, please stay behind. And some left, some stayed. We worked with the tenderer manufacturers on their individual products, and that was within the region of 10 to 15. And then eventually we got down to 3 garments or 3 manufacturers that would be happy to produce the PPE that we wanted. So they tendered, and then we ended up with the PPE that we wanted. Having said that, there was a lot of, it sounds very quick, but there was a lot of clarification processes, a lot of commercial confidentiality issues that we had to address in terms of making sure that what we said to one manufacturer wasn't passed on to another. And then there was the trials with our operational crews to make sure that what they were potentially getting with these 3 providers was what they wanted. So our new PPE, and I'll show it to you here, is based on 2 layers. That's the most layers that we could get it down to, and I'll explain why in a minute. Basically, we've got a wet legs, and they're here for your if you're interested, I'll pass them around the room. Basically, a standard wet leg. We decided that whilst we can have multiple layers on the top, having multiple layers on the bottom will be too constraining in terms of changing from operational incident to operational incident. But also, our fire appliances aren't the size of the American ones. Ours are more not as shiny. They're not as shiny. I say that. So we had a standard wet leg, but obviously manufactured to our design. A lot more knee padding than you'd find in normal standard PPE. The reason for that is because a lot of our training has been get down low, get on your knees, into the fire, and then we hadn't provided the PPE, suitable PPE for that to do so. We wanted to make it lighter because even in Manchester, within 25 minutes of being in a city centre, so you could be at the City Stadium, within 25 minutes you can be on moorland. So the same PPE, whether you're in a structural fire and then walking on moorland, has to be comfortable, has to be lightweight. And then you have the 2 layers. So you've got the mid layer, which is the bright one. This is mine. I have 2 sets. I have a dirty set for anybody who's interested. I'd still go to fires. Honestly, this is my second set. You have a mid layer, and this is meets standards for road traffic collisions, moorland fires, basic small non-structural fires. It meets all that. It also obviously meets the conspicuity elements of road traffic collisions, railway incidents, and etc. But again, it's designed with the help of firefighters, and specifically, I think, for operational officers. The reason I say that is you'll see quite a few pockets on there, quite a few attachments where you can put your fireground radio, things like that an officer needs. Now, generally, and this is general because we do have some specialisms, I would only, as an officer, would be provided 2 sets of this and then not be allowed to have the next layer on top because they don't trust me to go into fires. So we'd give them that because we know that we wouldn't be sending them in to fires. And then for those people who have to wear breathing apparatus as part of their role, although everybody in Greater Manchester Fire and Rescue Service, from firefighter to chief, has to be trained in breathing apparatus. For those who do enter compartment fires, this layer then goes on top. There was some challenge in terms of knowing, well, you know, whether the mid layer was being worn, but you can see, hopefully, from the picture on the right-hand side, the collar, and you instantly know they have got the mid layer on. In terms of feedback from the troops, they're ecstatic about it. There is some elements in terms of firefighters' feedback where they said they felt that it was warmer than the old PPE. And I say that now in honesty because part of the reason to do this was to go away from being warmer in it. Well, the research that we did, and again, every element that I'll cover today, has had that academic rigour behind it. So we had Leeds University undertake core body temperature analysis in our old PPE and in this PPE. So we had a number of firefighters in a room on a jogger, walking very fast, we're not that bad, walking very fast and measuring their core body temperature to make sure that actually this and all the other ones that we tried was an improvement in what we had before. So we know, whilst they may say that, we have evidence to say, actually, it's not warmer than the old PPE. And that's very important in everything we've done here. Again, you can see we haven't paid them to smile. They are that happy. You'd be surprised. People who work for me are that happy. So you can see there that, again, the difference. Ultra high pressure. Now, if I work back, the reason for this PPE was to provide them more comfort, more protection, and better PPE when entering the building. But the whole emphasis behind the Future Firefighting Project was actually to reduce the need for firefighters to go into the building in the first place. If we can, yes, we recognise that prevention has a massive effect on reducing the incidents, but they still happen. So if they still happen, we need to train for it, be prepared for it, and be prepared to go in and save lives and put our own lives at risk to do so. Absolutely, fully supportive of that, and we'll support every firefighter in doing that. But we want to, as much as possible, reduce the need for them to go in, and if we can't reduce the need for them to go in, reduce the or improve the environment in that compartment or in that building before they have to go in. So they're in there in an environment more suited to their health and safety, and to speed up the efficiency of attack, etc., etc. So we looked at a number of things, and ultra-high pressure cold cutting was the element that we thought was would be most beneficial to Greater Manchester. So in terms of the background for that, we reviewed our current practices in terms of how we fight fires, and basically our firefighting, again, I'm not too sure in terms of colleagues around the room, our firefighting in the past has literally been turn up, within a couple of seconds, kick the door down, go in with BA, hose reel, find the fire, put it out. Relatively no use of modern firefighting techniques. Yes, we do gas cooling if it's suitable at that incident, but the use of thermal imaging cameras, the use of tactical ventilation, not used greatly at all. We had done hot fire training, so again, gas cooling. And we had been using positive pressure ventilation fans for some years, doing post-fire ventilation. And that had been embedded for some time, and we'd got used to that. But again, it hadn't been a massive step forward. So we looked at our standard firefighting options and tactics, and thought, well, they've suited us to a degree, but we thought there must be better stuff out there. So we looked at other research, and I don't know if anybody's heard of the firefighter. Now, I sometimes get this wrong, whether it's a Firefighter 2 or Firefight 2 project. But it was a European project that actually started off the ultra-high pressure cold cutting system and attacked the offensive use of PPV. Did anybody hear of that project at all? And then we learned a lot from a fire and rescue service in the UK called Northants. They've done a lot in cold cutting and implement it on a number of their fire engines at the time. And then we visited Sweden, Boris, where they'd been using ultra-high pressure, again, in a form for some years. And that form was strategically placing cold cutting systems for use at fires, but not on every fire engine. So there was a limitation to how fast they could respond and provide that ultra-high pressure system. We also then, having taken all that on board, asked the FPA, Fire Protection Association, to undertake some research into other areas that we were unsure of our organisational stance on it. And I'll talk you through those now. Those concern stroke organisational stance was, if we were to use ultra-high pressure in a compartment where a member of the public was, what harm would that introduction of ultra-high pressure, not so much for me being a cutting tool, but the fact of an introduction of high-pressure water mist in a fire compartment, what harm would that cause, if any, to a member of the public in that compartment. Dr. Jim McLaughlin did the research for us, and the report has just arrived with me. I will make that available to people. But they baselined it. They undertook a number of live burn tests using a number of different ultra-high pressure cold cutting systems. Our fire engines are fitted with a Cobra system, but there are other systems out there, so he did try a number of different ones. He looked at the impact of water flow on performance and the safety tests. He also looked at wind-assisted fires in terms of ultra-high pressure and where the occupant was located. In summary, the research has shown that there can be an effect on the air tract when the water mist turns into steam. It depends obviously depends on where that occupant is. But again, the reduction of that harm can be assisted by our normal fire safety prevention information that we tell people. So close your doors. So move away from the fire, close your door. So if you're not in the compartment, that's one thing. Get down low. Again, that assists. So we felt that with our current fire prevention communication and our initiatives, that any introduction, if the member of the public was in that compartment, and 99% of the time, the occupant is either not in that compartment where the fire is, or in such a state that the water mist at that stage wouldn't have harmed him anyway, any further than the smoke and flames would have harmed him already. Occupant clothing also assists in terms of protection from steam burns, and again, we recognise that. Ultra-high pressure, the system, just to go into a little bit of detail in terms of how our firefighters took it on. We purchased 2 units for training. So we've got 47 fire engines now across the service with ultra-high pressure cold cutting on. We have the 41 frontline fire engines at each station, so 1 at each fire station. We have 1 research and development appliance, which is an appliance that is set aside for us to try new equipment on and new tactics on. That then, so for example, we put a new ladder on there, for example. It goes out to the crews, they try it, give us their feedback, and it comes back. We have 3 reserve appliances to make sure that we have ultra-high pressure available 24/7 at each station. And again, as I said, 2 training units. The challenges for implementing this, though, was in the past, the cold cutting systems have had their own engine with them. So you've bought the unit on its own, and it's had its own engine to drive the pump. We didn't want that extra weight, so we removed the engine and took it from the PTO, or the power takeoff. So the whole system, as well as a standard pump, is driven by the engine of the fire engine. Cost was, again, a challenge. We are talking around the £40,000 per unit. But when you equate that to the potential for reducing the chance of injury to our firefighters by sending them into compartments, the knockdown of the incident faster, the environmental impact of for those who know about the high pressure cold cutting systems, they use a lot less water than our standard pumps, so we eventually being able to reduce the amount of water we carry. As I mentioned before, we know that our average fire is 200 litres of water. So the system we have is a 56 litre per minute unit. So again, we don't particularly need, unless it's a significant fire, the 1,800 litres that we carry on each fire engine in Greater Manchester. The next one for us was the wired and wireless system. For those who do know about the ultra-high pressure, our system in particular is in the UK as the majority have been wireless. Well, in Greater Manchester, we decided to go with a wired system because of the fact that our built environment, with all the radio signals and the challenges with the construction of buildings, was such that we weren't completely comfortable with the fact of a system being run on a wireless system that could be affected by a number of those elements. So we went for a wired system. So we retrofitted all of our all of the 47 appliances. Again, with staff engagement, and this is a big part for us, has been taking our firefighters with us. We've had a group put together to say, right, when we're putting this equipment on there, what equipment are you wanting us to take off, because we're going to need to find room for this equipment. So they decided to take 7 lengths of 70mm hose. For those who don't know, we have 3 types of hose: the 22mm hose, which I'll go into in a little while, the 45 red lay flat hose, and then the 70mm hose. And they decided to take off the larger hose because they didn't feel it's warranted. Again, this is all down to the sheer dynamics of your own fire and rescue service. Currently, and this is only currently because we don't know where the financial climate will take us, we can get 10 appliances in Manchester City Centre within 10 minutes. So therefore, you've always got that backup, that support of fire engines with red hose, lay flat hose on if you need it. Again, we consulted staff. CAN bus system is making sure that all the electronics on the fire engines talk to each other. That was a little bit of a challenge, but we got there eventually. Moving the appliances around. Again, firefighters, for those who have obviously worked with firefighters and know them, when they get a new fire engine, are quite keen to keep that new fire engine, but we wanted our newest fire engines having this kit on, so therefore we had to take new fire engines from those crews and give them to other stations. So that was a little bit of a challenge, but taken in good stead by the firefighters. And the appliance age was a challenge. The average age of our fire appliance is 6 years old. We generally change at 12 to 14 years. That may be extended over the next couple of years, but we wanted to make sure again that our newest fire engines had the kit on. Financial, as I said to you before, the estimated cost, you only have to times that by 47 times, and you can understand how costly the project has been. And the fire cover, making sure that we had the fire engines, when they were being retrofitted, backfilled with other appliances, so we always had fire engines available. Task analysis is something that might interest you. I don't know if, again, from your fire and rescue services, your areas of work, a task analysis is for every incident type that we face in the UK, there's been a national project to say how many firefighters you need to undertake or to deal with that type of fire. And it's broken down to every individual's task. So, for example, for us, for a house fire, for a normal domestic property, for us, we say 12 people. So we have 4 people on a fire engine. So that's for a normal house fire, we have 3 firefighters, 3 fire engines. And it really does help, when talking to representative bodies, when deciding what training you have to provide, what kit you have to provide, to have incident types broken down in that way, to say, right, who do you need to do what, it really does help. Yes, it's going to be challenging coming forward with the financial climate to say how you get those fire engines there, but it does really get everybody on the same page in terms of thinking, right, what do we need to provide our crews? And then, obviously, the training. We undertook 2 days training for each of our firefighters on there, and we decided that once 3 of the crew, as long as the officer in charge was trained, as long as 3 of the crew were trained in the use of ultra-high pressure, then they could use it operationally. And that took some time. Configuration. The blue is the ultra-high pressure on the same side as the high pressure, which is the yellow hose, and I'll talk you through that in a second. And as you can see, quite compact unit. Within Greater Manchester, we have a lot of architecturally significant buildings, and within the first day of launch, we had an incident in Greater Manchester, Albert Square, Manchester City Centre, where when we first rolled out this ultra-high pressure, we said that firefighters could only use it externally. So they'd have to be outside of the building using the equipment. Within the first 12 hours, we'd had firefighters use it internally. We have a term in the UK called operational discretion. I don't know if you've had that here, but it basically allows an incident commander to deviate from standard operating procedures as long as they've undertaken a number of things. Risk assessment, they've documented why, I don't mean write a report down, but documented why they've deviated from that. They've then gone back to the standard operating procedure as soon as possible. So for this one, this was an old building. It had been had a number of floors, and the basement in particular had false ceilings put into it. It also had false floors put in, and the only way to get into the fire was to get something through those layers, and the ultra high pressure proved very, very successful at that. And again, using the operational discretion was, actually there's no other way of firefighting this incident. We're going to use it inside, and as soon as possible come out and see how effective it's been. Just another picture of Salford Street, Salford, where we'd used it. And this picture actually shows the relatively full suite, which is our use of, so when the incident commander attends the incident, so they pull up on the fire engine, every fire engine has 2 thermal imaging cameras, one for the officer in charge, which is a small MITIC there, and an Argus in the back for firefighters. They thermal scan, see where the hot area is. They then direct if required, they direct the ultra high pressure to it, and then they had the PPV, the positive pressure ventilation fan ready to go if required. Hopefully, this will be the presentation. So that video was taken. We were lucky enough for Manchester City Council to give us a group of houses that they were going to knock down and allow us to do live burns at that and put our firefighters through it, test it, and video how we would use it operationally. You saw there a number of trials. One was obviously using the positive pressure ventilation fan, even though the fire was still going, just to prove to crews that if everything was put in place, you can do that. You can go, you might not have extinguished the fire completely, but if you know the outlet is clear, you have somebody watching it, and we've discussed as a group only over the last couple of days how effective it can be. You need to make sure that your checks and balances are there, but it can be a very, very effective tool. Again, with firefighters, actually implementing this piece of kit has been an interesting one, because there's been a lot said about ultra high pressure in terms of it being a panacea of firefighting and fire extinguishment. For us as a Greater Manchester Fire and Rescue Service, it's not. It's another tool in the box, and I'll talk about another one in a minute. It's just, it suits a number of incidents, a certain type of incident, a certain scale of incident, but it won't do it every incident type, every fire type, every building construction. So, again, there's a lot to learn. We've used it in incidents where you just generally wouldn't have thought to use it. We get a lot of fires in, or get a number, I shouldn't say a lot, we get a number of fires in restaurants and fast food takeaways in terms of their ducting, and it's very effective in terms of making an injection point in there and extinguishing a fire in ducting. So that's been really helpful. There's some challenges for us. We're asking the FPA to do some more research, primarily of the use of multiple lances on large-scale buildings. The effects on the air tract, I've told you before. There's some counter work that we want to be undertaken with that as well. Large commercial I mentioned to you before, a national group being set up, and there's a lot in terms of development of the equipment that needs to take place for us. In Greater Manchester, we have a lot of high-rise buildings, and the standard ultra-high pressure system comes with a hose reel of 80 metres in length. For us to be able to use it for high-rise buildings, 80 metres is not long enough. So we've worked with the manufacturer. Now all of our fire engines will be able to connect to each other if you really wanted to, but you can extend it, so you can extend that hose further. And I'll tell you a figure now, but it's kind of irrelevant how fast it cuts. But if you extend the hose for hours to 3 lengths, that means for us it's 240 metres. It can cut a 1/4 inch steel in 30 seconds. Now I say that because that's a figure that's quite helpful to use and quite an analogy. But the thing is, the chance if you ever needed to cut 1/4 inch steel that distance is not there. What it will do though is it will provide you an effective ultra high pressure water mist at that length, at that height as well. So we're finding it very useful for an attack method for high-rise buildings if the need arises. I said a high-rise there. 22 mil. I will progress with 22 mil. I just want to open the floor up to anybody in terms of questions about ultra high pressure, if you have any at this stage before I progress on to the next one. Conscious that for some of you, ultra high pressure is well known to you, been kind of looked at, been researched in terms of your own fire and rescue service or your own area of work, and decided against it. The main reason we went for it was recognised for us in the UK or in Greater Manchester that we had to get saturation point for it to be effective. If it's not there early enough in the incident, then firefighters have already made their entry, they're already in there with the hose reel, it's irrelevant after that because they're already on top of the fire. So the only way that we thought it would be effective to stop firefighters going in there is if they've got it there as a first tool, and that meant all of our 41 fire stations having it instantly available. 22 mil hose reel. We have for some time had 55 to 60 metres of hose reel on our fire engines. It's been generally 19 millimetre across the service, and it has been the workhorse of the firefighters. It's been their bread and butter tool for a number of decades. Fast and effective attack, or so we thought. Some time ago, we had an incident in Bolton, if you've heard of Bolton, where a firefighter was very seriously injured going into a fire without water. He went into that fire without water for a number of reasons. When they arrived at the incident, the firefighters went with their hose reel. They had breathe apparatus on, etc., etc. But the building, the entry point for the building was too far away from the first 60 metres, and they tried to extend the hose, so decouple it from the drum and then connect it to another one. Unfortunately, in the enthusiasm of the public, they were pulling it that tight that the firefighters couldn't decouple it. The firefighters heard screaming from the members of the public in the building, and then 4 made an entry, and unfortunately flashed over without any water. And Steve Morris he survived, and he's in good health now, but he significant skin burns. The reason I bring that up is not because 22mm hose reels would have stopped that in the first case, but we did some research after that to say, right, how much water do we need to provide our firefighters? Has anybody heard of Paul Grimwood from the UK? Yeah, I see some smiles there. I hope that's positive. I'm sure it is. Paul's a nice guy. From our point of view, we did some research on our hose reels at the time to say, right, okay, would we have provided enough water, and are we providing enough water? And we recognised that we weren't, in fact. We were providing between 80 to 120 litres a minute. Paul Grimwood's research, and I'm conscious that people will challenge his research, may not agree with it, especially after the fact I just said to you that on average our fires only need 200 litres anyway to extinguish. On what his research has basically said is you need 230 plus litres per minute. And we weren't providing that through our 19mm hose. So we started from first principles. We started with the pump. So we stripped out our research and development pump. We tested the water coming out straight out the pump. Said, right, how much are we getting there? Then we added the connections to the hose reel drum. We were losing flow there, so we changed those connections. We then measured the drum. We were losing flow there. We changed the drums. We got to the hose reel, losing. And we got to the point where we just changed everything, because there was a pinch point no matter where we went to. And we got to the point where we are now. Plumbing, hose reels changed again. I won't go into too much detail there, but we tested all our branches to find out and that's not just the hose reel branches, but all our branches, to understand exactly what we actually had provide our crews, because you'd be surprised, I'm sure it's the same within your areas of work. Information comes from years gone by about what equipment does what. If it's not in black and white and there's not a manufacturer's guidance stroke technical specification with it, a lot of it goes untested, unjustified, and unrecorded. So we did that. Paul Grimwood again said, and the other thing is, with the ultra high pressure, we'd instigated the pump running to be effective on ultra high pressure at 2,500 revs per minute. So what would our high pressure hose work? How effectively would it work at that revs? So we recognised that 230 litres a minute required. 19mm didn't do that. Solution was increase the diameter to 22mm, re-engineer the plumbing, and go to the yellow super slip. Now, you would have seen the yellow hose. Hopefully you'd seen it in the video and saw it on some of the other pictures. We went for yellow because we'd gone from 19mm, which was black, to yellow. That means if a firefighter turned up at an incident where there was a different pump and it was black hose, they knew that was the old 19mm. And if they turned up and they saw it as yellow hose, then it was 22mm. We've replaced it all, but as I'm sure you can appreciate, changing hose reels on 56 fire engines all in one day is a nigh impossibility. So that's why we did it in that way, and it's been very, very effective. More effective than we thought, and this is another one in terms of engaging with your staff. We've gone from them being very keen and very excited about the use of ultra high pressure because it was a new piece of kit. We then further improved their bread and butter piece of kit, which is a hose reel, and now you've got a case where firefighters, again, that feeling of, to some degree, invincibility, having that 230 litres in their hand means they feel like they can do anything with it, and not fully grasping. And we're doing our best to push this. Is we don't want you to go in there anyway. Don't go in there unless you have to. And that's not because we're concerned about the impression given. We're not risk averse in the UK Fire and Rescue Service, but what we do is take a risk-based approach, putting our firefighters at risk if the need arises, not just because they can do. Yes?
Any problem with the visibility and the weight of the new houses?
Interestingly enough, 10 years ago, before we went to this new 22mm hose, I asked exactly the same question, because some 10 years ago we tried 22mm hose. I wasn't at that level at that time, and it was challenged back. It was too heavy. It was too inflexible, but then there were some that said it was too flexible and it would crimp round doors or around corners or whatever the case may be. We actually weighed it, and I think it's something like 0.7 kilograms per meter heavier. We actually tried black in 22, and you couldn't really see the difference when laid on the floor in terms of size. The weight irrelevant, I think, at that weight difference. And we did we made a number of testing scenarios to test the fact that whether it would crimp or not. The flexibility we found as good as our old 19 mil, but it was something we were challenged by our firefighters. And we've had this now for 6 to 9 months, and we've not had a complaint yet. The slipness of it was another one that they said, well, we've tried the smooth hose before, and it moves too quickly through the hand, but we seem to have struck the balance with this one. Yes?
You're still using the same pump, just replacing the connectors and the hose?
Absolutely. Yeah, all because, and again, this is again with the element of research. There's people when you ask what you would see as the organisation or the service expert in something, you to some degree give them license to give their own opinion. And generally, in my service, if the fleet manager, chief engineer, had said, I can't get anything more out of my pumps, we have done for years, said, right, okay, if you've said that, that's fine, we'll forget it. This occasion, we said, well, if you don't do that, we're going to have to get new fire engines, because we need to, which meant that actually he had no choice but to strip it back and work with the engineers, with our mechanics, with our firefighters, to see that improvement all the way along. Thank you. As you can see the yellow hose there, quite visible. Air unit drone. Again, some would say, well, where does this sit in terms of firefighter safety and thermal loading? It sat very well in terms of new technology and us taking advantage as a fire and rescue service of the new technology out there. And I couldn't fully see it until we saw the air unit in operation. And now it's one of those that actually the hose reel is great, the ultra high pressure is great, but it's understated how effective the use of an air unit drone is in keeping firefighters safe. And as I'm looking around the room as incident commanders, giving people that overhead view of an incident is irreplaceable, because again, we've had this air unit on incidents where we've been 10, 15 floors up. There's no way, unless you got into a helicopter, an incident commander would have been able to see that perspective of that incident. They wouldn't have known where their firefighters were. And I've seen, I think if you go online actually onto YouTube, you'll find a picture of a video of an air unit, not a fire service air unit, but an air unit, a drone being used by a member of the public, that captures a firefighter in the north of England at an incident, and they were literally seconds away from falling through the roof of a burning building. When a member of the public showed the pictures from the drone to one of the firefighters, they withdrew, and then the building collapsed, or the roof collapsed. To see the perspective that this gives you, and then being able to size up the incident you're attending using that. So knowing actually you've got your appliances in the right place, you've ordered enough resources, because your perspective of something that's 10, 15 floors up, and then seeing from above, two completely different ones. So a very understated project, but from a firefighter safety perspective, absolutely invaluable. And I think that's why our firefighters have embraced this one as much. We have a CCTV, a closed circuit television, on all of our fire engines. If you're not already aware, we have 4 cameras on, one at front, one back, both sides. The reason we do that is because this time of year, or well, a number of times a year, but mostly at bonfire night, which is November the 5th, we are subject to, how can I say, interest by young people who like to throw toys at us. Generally, they're red and big, and they look like bricks. and in fact, you'll see if you Google it today, the Daily Mail, you'll see in West Yorkshire a firefighter only last night being attacked with fireworks. He's doing a bit of a river dance, I think, skipping the fireworks, but we still see it. So we saw the introduction of CCTV again for firefighter safety as a major step forward, and we've seen significant reductions in firefighter attacks because of that. It's horrendous that we have to talk about it, but unfortunately it is one of those things, and I don't know if you face it in your areas of work, but in the UK it's reduced significantly, but we still have it. Now the reason I brought that is because there was some concern about the use of CCTV by our firefighting colleagues. So people on the ground thought at first, concerned that having CCTV, it was Big Brother watching them, etc., etc. That has never been the case. We have used it for discipline on occasions where we've needed to, but most of the time, by far not. And in fact, on occasions, again, I hope this doesn't make people think too negative thoughts about the UK. We've had occasions where a fire engine has been parked up, putting out a fire, and literally somebody's driven past, opened their passenger door, and driven it into the fire engine, and then claimed that we've hit them. So we've downloaded the video, played it to police, and they've been obviously taken to court for damage to a fire engine stroke civil claims. So it's been invaluable. So we thought we would get some challenge from this, again, because CCTV, Big Brother, etc., etc. But because, again, this whole project has been about trying to stop firefighters going in if they don't need to, protecting them if they do go in, but actually then giving them a full picture of what's going on in there as much as we can do before they go in and whilst they're in there as well. So the air unit, sorry to...
This is the Skywatch X1, plug-in X1, and we're using it for the next 3 months as part of a conceptual trial to see whether it's worth Greater Manchester actually buying such a unit. It's the first time we've done it, and as I say, this is the unit we've chosen to run the trial with.
So tell us a bit more about how it actually works.
It's a quadcopter with 4 rotors, quite a simple design. Battery fits in the back, and it basically takes off like as per a helicopter. Get about 25 minutes use out of a battery. It'll go up to 10,000 foot, but we only fly up to 400 foot, and laterally it goes about 500 metres out, but we only fly at about 300 or 400 metres.
And tell us about the type of incidents that it can be used at.
Well, massive variety of incidents, from fires to water rescues to explosions to collapsed structures to CBRN incidents, or just basically any training where the lads want to get us down, film what they're doing, and then we can give them some footage and they can actually do a much better debrief afterwards than they can at the moment.
And tell us how it actually works. Who flies it?
I fly it. You need a qualified CAA pilot who has to go on a course to learn how to fly it. I have 4 ground crew who are trained up, but I only use 1 ground crew per incident, and he's basically my eyes in the sky keeping an eye on it while I fly it.
It's been on trial now for a few weeks, so where have we used it so far, and how has it benefited those incidents?
Incident-wise, we've done about 8 incidents so far, and every time it's worked absolutely perfectly. Whatever the incident commander wants out of the UAV, we've been able to deliver. Whether it's a thermal picture, whether it's an overview, or whether it's showing the surrounding area for water, where the smoke's going, whether traffic's affected, anything like that. And the footage has been absolutely crystal clear and superb.
So, as Chris Rainsford, who's all our pilots are CAA, Civil Aviation Authority approved, which you have to be in the UK to use them. We can only use them in certain environments. So I say that in terms of the air unit can be used, obviously, operationally at any time. But for training purposes, we'd have to go somewhere where there's no population in terms of flying overhead, etc., etc. We train it. We have 6 trained pilots, trained by Chris. It's whole time retained. I don't know if you understand the whole time. Basically, Chris would work a normal shift as a firefighter on an appliance, actually as a watch manager, and then during the night he would have a retained contract, so he'd come out at night to fly the UAV or unmanned aerial vehicle if required, or air unit if required. We support incidents in Cheshire. Did you see the Bosley incident in Cheshire, the wood mill, where they lost a number of members of the public? No. We used it then, which was helpful from an urban search and rescue point of view, because it could scan a large area very, very quickly with a thermal camera point of view. We also used it. We use it for counter-terrorism to some degree with the police. Also, we've used it recently at Strangeways prison, where one of the inmates decided to have a holiday on the roof for a couple of days, and it was a lot cheaper putting that up than it is to put a helicopter up in the air for 10,000, whatever, £1,000 an hour, whatever the police cost impact of that. So to put that up every couple of hours to make sure they're okay, and it's very intrusive. You can do it from 400 metres away. The chap didn't even know it was there. So it eventually came down, obviously. But so we've done some work for that, and it's an excellent collaboration tool. One of the things we use it for as well is risk information gathering. We have a system called OIS, Operation Information System, and we have a computer on every fire engine called a mobile data terminal, and for every building of interest, you can download the plans of the building. We have our crews going out doing site-specific information gathering, so they'll go and find out what the risks are in that building, and we can take overhead shots using the UAV then to give that incident commander that information. So it's been really helpful in terms of that. Just trying to bring it to a close now in terms of the future focus. Again, there's a couple of areas that I just want to talk you through where Greater Manchester is going in terms of our future focus. And that's, we feel that in terms of our firefighting and the tools that we provide our firefighters to extinguish a fire, yes, we've got some work to do in Greater Manchester on foam, and we know we've got some areas that we need to work on in terms of foam provision. We feel that we're giving them the PPE and the training, but we think there's a lot of new technology that we can take better advantage of in terms of their welfare, their knowing where they are, what they're doing at an incident that would help the incident commander and them going on in terms of a latter service. The reason I bring that up again is, as I said to you before, we'll be going from firefighters reaching the age of 50 to reaching the age of 60 before they retire. So there's an element of their welfare and making sure that we know in terms of the health risks that come with getting to the latter stage of your career at 60. So we want to be able to monitor them in an incident. The electronic cord and control is about knowing where our firefighters are. For those who don't know, I would suggest most fire and rescue services, I'm looking at the uniforms in the room, don't have a cord and control system past a tally system. So once they've gone into the building, you only have their word and the instruction you've given them to stay within an area. You can't guarantee it, and you don't know exactly where they were. So if you had to send in an emergency team to find them, you could only give them the same information that you gave the original crew before they went in, or any subsequent information that was sent out of that incident. So it's very much a finger in the air when you send the emergency team in to get them, or rapid intervention team as we have. We'd like to change that. We'd like to be able to say exactly where they are, so you can go to that place to find out. We'd like to know what they were doing. So if we have automatic distress units on our breathing apparatus, which are great, but again, your smartphones will tell you whether you've stopped moving, or your Apple Watch at the moment will tell you whether you've done enough steps today. So we want to try and combine some of that technology to help the incident commander outside of there, but also to gather that information, because currently we have no system to say that a firefighter has been to one incident, has been in temperatures of whatever degrees for aware of a breathing apparatus wear of 30 minutes, to then drive from that incident to then go to another one to do exactly the same, and what effect that has had on them. And we still get that in the UK. We still get the point of attending one incident and going straight, especially during the busy times of the year, going straight to another. And we want to be able to gather that information. Knowing, again, as I said to you before about core body temperature, we want to know what their temperatures are like. I don't know if you've read anything about the Special Air Service in the UK. who during their tests, you have to do a couple of tests. I'll say a couple of tests. You have to do a number of tests to join the SAS. And unfortunately, a couple of years ago, some soldiers, I think there was 2 or even 3 soldiers died during their pre-entry tests. And they put that down to the core body temperature, the temperature obviously on the day. And we've learned a lot from the Army about how we can look to monitoring core body temperature. And all that information would help in recognising then common injury trends, which we need to be aware of. Again, I talked to you about musculoskeletal, so that when we have our aging firefighters, we can give them the proactive education, stroke, medical support to get them back to operational duties. And then if that is not suitable for them, the last one, but a really important one for us going forward in Greater Manchester, for those who aren't aware, is our community risk intervention. So we've currently got all our firefighters going to cardiac arrests. We've just put out to tender for 6 vehicles only yesterday, probably going up to 13 vehicles, that will have a mixture of firefighting technology on and casualty care. I don't know if you have these in your areas. So you'll have an ultra-high pressure coal cutting system on there, which has a high pressure water mist facility as well, so it's not just ultra-high pressure. It'll have a positive pressure ventilation fan, have a number of firefighting pieces of equipment, but in the back it'll look like, you could say, a very, very, very basic ambulance. Clean, sterile area for somebody to put a casualty in there, not to transport them to hospital, but to deal with that casualty prior to an ambulance attending. So we'll deal with, as I said, cardiac arrest, potentially doing low-level medical interventions, because, again, we feel our firefighters have the ability, we'll train them and give them the skills to do those others, but we have the ability, and with our ever-decreasing operational workload from a fire and emergency point of view, we feel we have some capability in their daily work to support our National Health Service in doing that. So that'll be a big one for us. Our support and our drive to reduce fires, we feel, perfectly placed with our firefighters to help address some of the health care issues we have in the UK. And that's one way of doing it. But we'll see. And in that way, just going back to why we say that about ageing workforce, that we don't feel there'd be a need for that same firefighter who's going to the compartment to be able to do to be in the same physical condition as somebody who's going to be on this new type of vehicle, because they won't be doing compartment firefighters. Yes, it's still quite, well, it's not quite, it is physically demanding carrying out CPR, and there will be other elements that are physically demanding in that role, but it won't be the full spectrum that we expect our firefighters to do in terms of crawling through buildings, etc., etc. So we feel there's a way of maintaining the staff that we have doing a different type of role in our service. I hope that's been of interest to you, and if you've got any questions, please shout out. I don't know if you'd like to use a microphone. Can anybody? Do you want to speak up, and we'll see if it works without a microphone?
I think I'll manage. in the beginning, you told something about you had some results of a lot of fires that you only use about 200 liters of water.
Mm-hmm.
What have you done with that result, or are you going to do something with it?
Yeah. The question was. Yes, thank you very much. The question was, with the results of knowing that our average fire is 200 litres, it's getting worse, 200 litres, 200 litres, what, have we done anything with the results? I think that's a really interesting one, because for everything that we've said about standards, about how we are concerned about our firefighters' health and safety, I still feel that fire rescue services, ours, has been to some degree risk averse. We are still sticking with 1,800 litres of water on the fire engines. On our new appliances, these new community risk vehicles that I've just said, the 6 to 13, there will be around 300 litres on, only because there's not enough room for a start. but the surrounding fire rescue services have 1,000 litres on them, on their fire engines. And the majority of the UK fire and rescue services are at 1,800, despite there being a number of fire engines around them and being able to support them, and us not using that quantity of water. What we'd like to have done, and it's not hindsight, it's just how fast in the UK the political environment is moving and the financial one is, we have extended the life of our fire engines. If we were going to new fire engines, we would have reduced the quantity of water carried, most definitely, to below 1,000, I would suggest. Especially if we've got the same fire cover in terms of fire engines, that you can always get support there. We have good water matrix as well in Greater Manchester, so you can always get to a hydrant if you needed to get that additional water. But to some degree, the question is, do we need to carry 1,800 litres of water around all the time? No, we don't. It's not efficient. It's not environmentally friendly in any way, and we don't use it. But there's still that risk aversion, I would suggest. Any other questions? Thank you.
You said a lot about average fire, the average incident. And I think an interesting question is what do you prepare for? Do you prepare for the average, or do you, in some extent, prepare to Murphy's Law?
Yes, it's interesting because if you take that scenario that our average is 200 litres, and then our fire engines are 1,800, what's to say then that 1,800, if you go into 1,800 litres, is that enough? Because you don't go to 3,600? Because we've been challenged by our firefighters in some degree that I could see our vehicles in the UK. We've gone to smaller vehicles with less firefighters on, and the challenge is, well, we need those firefighters there in the early stages. Well, it's interesting. On 95% of occasions of incidents, you don't need them there in the early stage. And what an incident commander does, and looking around the room, you would then ask for additional resources to come. So what's the difference making the request with 2 or 3 firefighters there, right, I need more resources, than if you've got 4 or 5 engines and you need more? You still need to make up. There's no way we can send enough resources in terms of Murphy's Law to every incident. But again, a lot of this is driven through financial challenge and us driving down our demand.
But then it's not about only the liters of water you carry. Let's say the general approach is we do research, we have statistics, we have figures, and then what do we prepare for?
Mm.
How do we explain that to the politicians that we are maybe unable to take care of certain things?
You're absolutely right, and that's a challenge again for our workforce in the UK, where we're going to very much a more, not in Greater Manchester, but across the country, a more part-time firefighters. And the politicians will say you don't need that many firefighters there because you haven't got that many incidents. But when we have the big incident, you'd then be complaining that we've not got all the firefighters you need. So which one is it? You're absolutely right. Yeah. Any other questions? Good. I hope you've enjoyed it. My contact details, I'm sure, are available. I'm more than happy to send you any information you're interested in. And if anybody wants to visit Greater Manchester, I'll take you to a Man City game. I can't take you to a United one. As an Arsenal fan, it just goes completely against my religion. But more than welcome to come to Greater Manchester. So please take me up on the invite if you're ever there. Thank you very much.